As a part of Indian tradition, my mother, our mothers used to tell us that God is everywhere. But ladies and gentlemen, one more thing is there everywhere, that is tuberculosis. Welcome to 𝗖𝗵𝗵𝗵𝗺. This is Dr. 𝗵𝗵𝗺, your faculty of microbiology. We are going to discuss the topic of tuberculosis today, but one thing that is very important, it is the Mycobacterium tuberculosis which is responsible for causing tuberculosis. But Mycobacteria is not all alone TB. What I meant to say is that there is not only one species of Mycobacteria. Mycobacteria has got other species also, which you call it as atypical Mycobacteria. So, atypical Mycobacteria means Mycobacteria other than TB. Okay. So, first of all, let us discuss about Mycobacteria. So, I told you that Mycobacteria has got Mycobacterium tuberculosis, then atypical Mycobacteria, and of course Mycobacterium leprae. But leprae is responsible for causing leprosy, which is a skin disease. So, we have covered this. Coming on to Mycobacterium tuberculosis and atypical Mycobacteria. So, first of all, we will discuss Mycobacterium tuberculosis. But my dear friends, please remember one very important thing. Mycobacterium tuberculosis means Mycobacterium tuberculosis complex. It is a complex of acid-fast, non-motile, gram-positive bacteria anatomically. That means if you go into the anatomy of gram-positive bacteria, just like looking at their cell wall, etc., they are gram-positive, but they don't take up gram stain, or you can say they are lightly gram stained. So, because they are lightly gram stained, it becomes our responsibility to stain them darkly. And how will you stain them darkly? With the help of acid-fast stain. Okay, clear? Good. But one thing to remember, Mycobacterium tuberculosis is non-motile. As far as of now, I have told you that Mycobacterium tuberculosis is not alone, but a complex is there, which is a group of acid-fast, gram-positive, non-motile bacteria and consists of 4 important species: Mycobacterium tuberculosis, Mycobacterium bovis, Mycobacterium microti, Mycobacterium africanum. Right? Even if you are not able to learn them, understand Mycobacterium microti MM, not a big deal. Then you have got Mycobacterium tuberculosis TB, B say you remember bovis, from B you can remember bovis, and from B you can remember A as well, that is africanum. Africanum. But it is very important to discuss, see, microti and africanum are very rare in India. The most common ones are Mycobacterium tuberculosis and Mycobacterium bovis. So, my dear friends, it becomes a vital importance for us to understand these both, Mycobacterium tuberculosis as well as Mycobacterium bovis. I have told you n number of times that if it is the lung, then the bacteria wants to live in the top of this lung. Why? Because it is oxygen rich area. That is why Mycobacterium tuberculosis is an obligate aerob, whereas Mycobacterium bovis is a microaerophilic. I have given you a mnemonic, microaerophilic, the mnemonic was MLC, if you remember, MLC horrible, right? So, M for Mycobacterium only, okay? So, remember this is important, that these are microaerophilic. The second difference between both of them is, if you stain Mycobacterium tuberculosis, it is irregularly stained and it is bead shaped appearance, whereas bovis is a uniformly stained and slender appearance. Okay. So, how to remember? Remember TB, B for bead, and if I make this T as I, it is irregularly stained. So, converse is going to be the truth for bovis, then it is going to be uniformly stained and it is a slender shaped appearance. This was about the stain in the Zn stain. Then media, LJ media. In LJ media, Mycobacterium tuberculosis is responsible for forming buff. So remember, buff is important for TB. So TB, B is buff. Okay, so rough, tough, buff colonies. Rough, buff, tough colonies, and B and C come together. These are cauliflower-like colonies. Whereas bovis is going to have again B and C coming together. B for bovis. Bovis has got smooth, creamy colonies. Rough, buff, tough colonies for tuberculosis, whereas smooth, creamy colonies for bovis. In glycerol, the TB is going to grow. How to remember? See, tuberculosis has got a big spelling. Bovis is just a small spelling. So remember, Mycobacterium tuberculosis grows in glycerol, whereas bovis is not going to grow. And the last but not the least, the most important one, Mycobacterium tuberculosis is NNN positive. What is this NNN? NNN is not Neil, Nitin, Mukesh. It is niacin, neutral red and nitrate reductase. Okay, it is niacin, neutral red, nitrate reductase positive. Okay, so niacin, neutral red, nitrate reductase positive. So I've made it very simple for you. Yeah, NR, okay, NR, okay. Right now you all are NRIs, correct? Living in various countries, no? So NRIs. So anyways, so niacin, neutral red and nitrate reductase. So Mycobacterium bovis does not grow. I mean, it is nitrate negative, the niacin negative, nitrate reductase negative and neutral red negative. What are the virulence factor of Mycobacteria? So there was a reason I told you that Mycobacteria comes under MLCH, because MLC is the mnemonic for the virulence factor of Mycobacteria. That means M for MHSP, L for lamb, C for cord factor. M for MHSP means Mycobacterium heat shocked proteins. So Mycobacteria has got some proteins, heat shocked proteins, which serve as the virulent factors for Mycobacteria. Then L for lamb antigen, that is called as lipoarabinomannan. Actually, lipo means lipid part and mannan is a glucose, so it's a glycolipid. And then you have got cord factor, which is responsible for formation of macrophage inhibition and hence responsible for formation of serpentine colonies. Cord factor causes what? Causes the macrophage inhibition and responsible for serpentine colonies. So my dear friends, very simple to understand. One is the heat shocked protein, other is the lamb antigen, then is the cord factor. Cord factor is very important. Why? Because cord factor C and K are very similar, no? C for cord, K. So K for kills. Kills whom? Kills the macrophage. And once the macrophage is killed by the cord factor, the bacteria is going to grow and is responsible for forming what? For forming the serpentine colonies. Responsible for forming what? Serpentine colonies. So it is responsible for causing TB, that is pulmonary TB, and extrapulmonary TB can affect any organ except hair and nail. Hair and nail are not affected by tuberculosis. Important question. Hair and nail are not affected by what? Not affected by tuberculosis. Okay. So some other organs it can obviously affect. For example, if it is affecting spine, it is called as Pott's spine. Okay, it is known as what? It is known as Pott's spine. For example, if it is having a focus in lung, it is called as Ghon's focus. Right? So these 1-2 terminologies are actually important, so that's why I have told you. Okay. Now TB has a wide spread in India. I have told you in India there is a lot of TB which is there. That's why the very first vaccine which we give is the BCG vaccine. You know that the very first vaccine which is given, obviously the very first vaccine which is given is vitamin K. Okay, the first vaccine given to the baby is vitamin K on the shoulder, vitamin K, but the next one is, the first vaccine as per National Immunization Schedule, There is a card which is there, no, National Immunization Schedule is going to be BCG, okay, because TB is a lot, TB is a lot of times there in India. So basically we give BCG, that is for the protection against TB. But which TB? Extrapulmonary TB. This is a very important MCQ, my dear friends. BCG can prevent you from extrapulmonary TB, but pulmonary TB, the TB which is going to affect the lung, can't be prevented by BCG. Okay? Why? Because the major route of transmission is inhalation, and a very small infectious dose is capable enough to cause the infection in humans, and especially respiratory. Why? Because it is getting inhaled, and a very small infectious dose is capable of doing very big problems. I'll not take the name, but yes, one of my friend, he was posted in respiratory and TB unit, and yeah, obviously because of his own mistake, he was not wearing mask properly, he had port spine. And what is port spine? I've told you, if it is going to the spine, okay, that's the port spine because of TB only. So how to diagnose this? By the Zn stain. And how much H2SO4? 25% H2SO4 is required. Other stain is called as auramine rhodamine or auramine phenol stain. So these are the fluorescent stains. So whenever you pour this stain on Mycobacterium tuberculosis, it is going to give you some orange yellow colored fluorescence. Okay. Let me see if I got the pictures. Yeah. So basically it is responsible. Yeah. So in Zn stain, how does it look like? Just like I've told you that it is going to show beaded appearance. So if I just zoom it, can you see these are the different beaded appearances which is seen by the, which is given by the Mycobacterium tuberculosis. And yes, this is a miliary mottling which is happening. So miliary mottling means what? A lot of small, okay, I'll zoom in for you. Can you see these white, these white, these are just like millets, small millets, no? So miliary mottling which is going to occur because of many reasons. Actually, this is just the parenchyma being infected. Okay, so these millets are something which so I should say millets looking. Okay, so these looking like millets, what I should say, areas looking like millets contain infection, and one of the cause for miliary mottling, or you can say the most common cause for miliary mottling, is tuberculosis. Okay, tuberculosis. Clear? Good. Yeah. So coming on to the culture, I told you that previously we used to do solid cultures like LJ media, like Loeffler serum slope, like Dorset media. But the problem is that bacteria is a very slow growing organism, very slow growing organism. So that's why it was taking 6 to 8 weeks to diagnose TB, you know. That was the reason that bacteria, the TB was considered to be a deadly disease, because we were not able to even diagnose, even confirm the diagnosis, because it is a slow growing one. Okay. So Loeffler serum slope, LJ media, Dorset media, we used to use it before, but then now we are using liquid media either, which within 10 days, liquid media is called as Mycobacterium growth indicator tube, which is going to give results in just 10 days. Okay, and yes, you very well know rough, buff, tough colonies, cauliflower-like colonies, it is being formed by it. Okay, so yeah, this is it. This is about the culture media for the growth. Okay, mind you, I have also told you the stains as well. Yes, all these things are done. Yeah, coming on to the drugs. See, drugs obviously given for the TB is a part of discussion for pharmacology faculty, but for me it is important to tell you that why there is resistance being developed in bacteria, because of the, see, lot of time these drugs are being given and bacteria has now developed some resistance against them because of several genes. Okay, so this was my bacteria has started developing some genes which are going to kill the antibiotics. So antibiotics are being killed by the bacteria himself. Okay, so let me just tell you first of all we should know the names of drugs. So what are the drugs? So remember, the first line drugs are going to be HRZE, isoniazid, rifampicin, pyrazinamide, 𝗖𝗵𝗵𝗆𝗏. Initially, injection streptomycin was also given, but now it is not given. These are the first line drugs. And then you have got some second line drugs also, just like fluoroquinolones, injectables like kanamycin, capreomycin, amikacin, mainly the aminoglycoside group of antibodies. Oh my god, yeah, okay, all these things. And yeah, some other drugs also, let me just name them for you: cycloserine, delamanid, bedaquiline. Okay, right. Okay, which is the regimen now being followed? So what happens is, so if I just tell you about HRZE, so the thing is that you have got two phases. One is for the intensive phase and the continuous phase. Okay, so basically leave whatever the thing is, intensive phase, continuous phase. These all things are actually the domain of pharmacology faculty. I will not teach you in detail, but my part is the drug resistance. So first of all, what do you mean by monodrug resistant bacteria? So monodrug resistance means resistance to H, that is the isoniazid resistance. Then comes the other resistance, that is called as rifampicin resistance. That means R resistance, but R resistance is always with the H resistance altogether. So this is both R and H resistance, that is important. Clear? So what is MDR now? MDR means multi-drug resistance, that means resistance to isoniazid and rifampicin. So I and H, if both of them are resistant, that is called as multi-drug resistance or MDR TB. Next is the XDR TB. XDR TB means MDR TB plus resistance to any one second line injectable like kanamycin, capreomycin and amikacin or fluoroquinolone, any one of them, then it is considered to be XDR TB. But what is important as per microbiology is what are the genes involved for the resistance. So remember, for isoniazid the resistance is CAT gene and INHA gene, whereas for rifampicin it is RPOB gene. So it's very simple to understand that for INH gene isoniazid, R rifampicin, RPOB gene. Okay, so this is important. Okay, and for fluoroquinolone resistance it is the GYRA gene. So if you remember, EFGH are very close to each other. So F for fluoroquinolones and G for GYRA is going to be the gene responsible for the resistance. This I have told you. So how will you know that drug resistance? With the help of CBNAT. With the help of CBNAT, and that's are of two types, gene expert and line probe assay. So gene expert takes approximately 2 hours, okay? Because it is an expert, it's very early, and it is mainly in order to diagnose the resistance against the rifampicin. Okay, and after that you can do line probe assay, and line probe assay is also of two types, FLLPA and SLLPA. So FL means first line drugs, FL means first line probe assay, and second line probe assay. What does that mean? First line means it is going to check for what? The first line agents. Second line means checking for the second line agents. Coming on to the atypical mycobacteria, that is also called as ATM or NTM. NTM means non-tubercular mycobacteria, also called as MOTT, that is Mycobacteria other than tuberculosis. So, how to divide them? First of all, in order to divide them, I think you should know that there are slow growers. So, some bacteria, some mycobacteria are slow growers, just like even Mycobacterium tuberculosis is also a slow growing TB. So, some are slow growers and some are rapid growers. So, rapid grower means they are going to grow in less than 1 week, whereas rest of them they need 6 to 8 weeks. So, first of all, let us understand about the rapid growers. So, who are the rapid growers? Rapid growers are Smegmatis, Chiloni, Photochromogens, Abscession and Mucogenicum. So, very simple to tell you. See, the ones which are having just the name of some fluid, they are rapid growers. For example, see Smegmatis, so having smegma word in it. Okay. Mucogenicum means mucus is there. Abscession, that means abscess is there. Okay. So, they are going to grow rapidly. Okay. And then Photochromogens, okay, if you write fluid in here, very easy for you to understand. Okay. Chiloni is something, in Hindi we say chalona. Chalo means chalna, means moving. So, somebody who is moving is fast only, so they are also fast growers. So, these are my tricks to remember the rapid growers one. Okay. Whereas the slow growers are these. Now, slow growers were divided by Runyon. Runyon was the scientist or the microbiologist who divided the slow growers into 3 parts. One is called as photochromogen, scotochromogen, non-chromogen. Photo means light. Chromogen means genesis of chromone. Chromogens means genesis of what? Pigment. So, photochromogens means pigment is produced in the presence of light. Scotochromogen means pigment produced in the absence of light in the dark. And non-chromogens means I am not going to secrete any pigment, you do whatever you want to do, no pigment from my side. Okay. So, see the examples. Photochromogen. So, P for photochromogen, P for we have the mnemonic PSM king. So, who is the PSM king? Yes, who is teaching the PSM to you? Comment down. Okay. So, PSM king. Okay. So, PSM king. So, P for photochromogen. Yes. S for 𝗲𝗵𝗶𝗵𝗵. M for marinum. K for kansasii. These are photochromogen. So, obviously because they are king, king will obviously sit in the light position, in the light. Whereas, if you see scotochromogens, just remember 2 most important examples. They are Gordoni and Scrophultium. They are Gordoni and Scrophultium. It's very easy to remember. S for Scrophultium. And whom do you remember when you are in dark? You remember God. So, God for Gordoni. And then non-chromogens. So, remember who are non-chromogens? Non-chromogens are 𝗵𝗵𝗻, intracellular, ulcerans, 𝗲𝗵𝗵𝗵. Okay. So, non-chromogens means not, knots means just like cross. So, cross can make you remember about 𝗲𝗵𝗵𝗵, and other are actually the vowels only, A, E, I, O, U. So, A for 𝗵𝗵𝗻, U for ulcerans and I for intracellular. So, you have to exempt out E and O from it. What are the clinical features? So, some clinical features are important, just like marinum, as the name suggests, marinum. Marinum means in marine water. So, fish tank granuloma and swimming pool granuloma, they are going to cause. Okay. So, fish tank granuloma and swimming pool granuloma, that's easy to remember. Then ulcerans responsible for causing ulcers, and these ulcers are called as Bruley ulcers. Which ulcers? Bruley ulcers. Then 𝗲𝗵𝗵𝗵𝗵, I told you, cross, stay away, cross. Stay away means I am telling you to stay away, and you people are medico fellows, please stay away. Why? Because it causes what? Hospital outbreaks. 𝗲𝗵𝗵𝗵𝗵, cross, dangerous, please stay away. You people should stay away because you are going to the hospital. Hospital outbreaks caused by X, that is 𝗲𝗵𝗵𝗵𝗵. Coming on to opportunistic infections. So, please remember opportunistic infection starting from O, again A, E, I, O, U. So, remember A for 𝗵𝗵𝗻, I for intracellular, O for opportunistic infections are being caused. Coming on to the one which mimics tuberculosis, that's going to be Mycobacterium kansasii. That's going to be Mycobacterium kansasii. That is going to Mycobacterium kansasii that mimics the TB. Okay, and then you have got battery bacillus. Okay. Now, how to remember kansasii? Remember this S for same. So, same like TB is kansasii. Next is battery bacillus, that is intracellular AE. Supposedly there is, okay, so I don't know if you call it or not, but in India we call batteries at cells. Okay, batteries and cells are almost similar things. So, battery means bacillus battery and cells means cellular AE, intracellular AE. And coming on to endoscope contamination, that is by Chiloni. Okay, endoscope contamination is by what? Is by Chiloni. Clear? Okay, so endoscope is, yeah, Chiloni, see last mein E and this is also E, so E and E you can remember like that. So, what are the enzymes which you will use for the atypical mycobacteria? So, amidase, aryl sulfatase and then 𝗲𝗏𝗵𝗵𝗺. So, it is positive for non-tubercular whereas negative for Mycobacterium tuberculosis. So, amidase, aryl sulfatase and 𝗲𝗏𝗵𝗵𝗺. Okay. So, that is why I always say whenever you write atypical, A and T are very important. A for amidase, A for aryl sulfatase and T for 𝗲𝗏𝗵𝗵𝗺, positive for non-tubercular mycobacteria. What is the treatment? Treatment is going to be azithromycin and rifampicin. Okay, these are the treatment options. These both images we have already discussed. So, okay, yes. So, this marks the end of our session, a little longer but very important and productive session for your YY exams, especially for your MCQ exams especially. This is very, very important, and of course for any competitive exam, this lecture is just like must know topic. Even if it is for your theory exam, I think by writing 1, 2, 3, 4, I have written all the examinations for which this topic is important for. So, please don't drop this topic. Make sure that you do this topic in a very well organized manner. Thank you so much for joining. God bless you.